we did math. Okay, so using those colors can be helpful to be able to decode, like, oh, what were we actually looking at? If you don't want to use colors, again, these are your notes. It's your choice. I highly recommend it. It helps me a lot, but maybe it doesn't help you. IDK. All right, 5-2, bisectors and triangles. So we're going to start with the circumcenter. So when we talk about circumcenter, we have this prefix circum. Okay, another math word that starts with that prefix circum is circumference. If you think about circumference, what kind of shape are we dealing with? A circle, yeah. So that's what a circumcenter, it's going to be dealing with circles. Circum means to be like around. So if you think about circumstances, circumstances are all like the situations that are happening around something specific. So circum means around, okay? So circumcenter, we're going to be talking about a circle. So circumcenter, this is going to be a, I forgot the word for it. Sorry, the new practices say it weird, and I just want to make sure I'm saying it right, because I definitely don't have the right word in my brain right now. A circumscribed. Okay, so we're going to have a circumscribed circle. A circumscribed circle. We'll talk about that in just a second. Probably should put that second, sorry. All right, so circumcenters are made out of all of the perpendicular bisectors. Circumcenters are made out of all the perpendicular bisectors. So as I take a look at this triangle, I'm going to start with triangle ABC. We're looking at this big triangle. That's how this is created. It's making this first triangle, the big triangle first. Okay. Then what it's going to do is it's going to find the midpoints of each side. So we're cutting each side in half. So I have F is the midpoint of BC, which tells us that BF is the same as FC. These would be matching because it's the midpoint. Okay, where would be another midpoint? D. D is another midpoint, which means that what two parts are the same? B to D and D to A. They have these two tick marks there. And then again, we have one more here where we have that midpoint. This time we have 3 and 3. So remember when we have those amounts of tick marks, we're matching the same amount with the same amount. So these ones match because it's 3 and 3. These ones match because it's 2 and 2. These ones match because it's 1 and 1. These ones do not match. 1 and 3 cannot go together. Even though they both have tick marks, it's not the same amount. Okay, and then we have these perpendicular bisectors. So remember, perpendicular bisectors is where we have that 90-degree angle. Oh, no. A pencil. Sorry. Okay, I guess I'm using green. Sorry. I'm switching to green because my yellow is too short, too sharpened. Okay, so we have these 90-degree angles here. My green also needs to be sharpened. Do you guys have an extra yellow? Can't feel it. Ah! Thank you. Sorry. All right, so we have this one here. So we're making these perpendicular bisectors, and they all intersect at P. So we're thinking F to P, E to P, and D to P. So all of these perpendicular bisectors are not equal, but what it creates is a point that is the circumcenter. So P is the circumcenter of this triangle. And what that means is if I draw a circle around this point, my circumscribed circle, it's going to capture each vertex of the triangle. So if I think about this and I try and make a circle around that point, this is my middle of the circle. I'm drawing that circle. It's not a very good one. There we go. Okay, and with that P, that circle touches A, B, and C. That triangle is now encased inside that circle. It's circumscribed. And in a circle, we know that each radius is the same. So going from the center to the edge would be the same. So if I go from the center to the edge of the circle, what point is on the edge of the circle here? A. So if I go from P to A, that's going to be the same as, where's another radius? P to B. Which would be the same as, what's our last one? P to C. So that's what a circumcenter does, is a circumcenter allows it from that point to be the same distance from each vertex. So if you imagine like you're standing or you're babysitting and you have 3 kids that you're babysitting and you want to be the same distance from each kid. You have kid A, B, and C. You're standing right in the middle of A, B, and C. So you can keep an eye on each of them. Okay. So let's on this next one, we're just going to write down what we know about it. There's not a whole lot. The questions on the practice today are going to give you one of the numbers, and then you have to know which one it's equal to. So that's what we're going to just do with this last one, is just write all the parts that we know. Okay, so as we take a look at this one, we have triangle ABC. So this one's kind of goofy. It's hard to see as you start. So first thing, when it's drawn for you, you have to identify where that triangle is. So we have triangle A, B, and C. Okay, and then we have point D is my circumcenter. So because point D is my circumcenter, I know point D is made out of the perpendicular bisectors. So that's going to be my first thing here, is to identify my perpendicular bisectors. So what parts are going to be the same here? If it's a midpoint, I would know that if E is a midpoint, A to E is the same as E to C. So I'm going to do 1 tick mark and 1 tick mark. Those are the same. Okay, where else could I mark some tick marks here? Good, C to F and FB. And where else? Good. B to H and H to A. And that one's kind of a tricky one to get in there because there's some lines going on. But okay, if you want to write that out, that each one is a midpoint, we could write each one out saying AE is congruent to EC. That's what those tick marks mean. So if you need to write that in there just as a reminder of what each one means, you could write up here CF is congruent to FB. I'm going to just write this one just to remind myself that's what the tick marks mean, is that these are the same. Okay, then we make the perpendicular bisectors. So is the perpendicular bisector going to be A to D, E to D, or C to D? Which one is the perpendicular bisector? AD, sorry, that's an F. Is that an E? ED, and then CD. Which one is the perpendicular bisector? CD is a perpendicular bisector? Perpendicular means how many degrees again? 90. So I'm looking for that right angle, that little box, that square. So my perpendicular bisectors here are E to D. It's from those midpoints to that middle that are connected. So where else do I have one? F to D. And then my last one is kind of hidden. It's at H to D. These all intersect at point D, which means D is the circumcenter. And if I drew a circle around D, it would have points A, B, and C. They'd kind of all be on the same side of the circle this time. So there'd be a lot of circle over here, and then they'd hit all three over here. Because A, B, and C are all in the same circle, what parts are going to be the radius, or radii? It would be D to A. So AD is going to be congruent to, good, DB. I'm going to write it as BD, but you can write it as DB, either way. Is congruent to, what is it also the same as? Yep, DC or CD. All right, so those are circumcenters. Circumcenters are created by those perpendicular bisectors. Next, we have incenters, which, looking back at yesterday's notes, what might an incenter include or be made out of? What was our other type of bisector we worked with? We did perpendicular bisectors, and then we also did what other kind of bisectors? Thanks, angle bisectors. So this one is going to be made out of all the angle bisectors. Yeah, really leave a lot of room there. So as I look at each angle of the triangle, I'm starting with triangle ABC. I'm going to mark all those angle bisectors. So in each angle, we're cutting it right in the middle. So as I take a look at angle A is getting cut right down the middle, and I can tell that from these arcs. There's two here, two here. I'm just going to shade those in so I see those. Okay, then I go to the next angle of the triangle. So I'd go to angle B, or you could go to angle C, doesn't matter. And I'm going to cut angle B right in the middle. And again, I know it's right in the middle because we have those little arcs showing us that this angle is the same as the other angle. And then I go to my last angle, angle C, and cut that down the middle. Now this time when we have an incenter, our incenter is P. What this is an inscribed angle, or sorry, an inscribed circle. So an inscribed angle is not angle. Oh my gosh, Miss Morrell, get your life together. Inscribed circle. Inscribed angles are chapter 10. Sorry. Getting my chapter 5 and chapter 10 mixed up. I don't know why. Okay, inscribed circle. Inscribed means it's inside. So now if I draw a circle around P and I make a circle, the circle is going to be inside the triangle. It fits inside of it. And that circle inside hits each of the sides. It doesn't hit the middle points of each side, but it hits each side of that triangle. So again, now we're looking at those radiuses, or the radii, and saying the radii are all equal. So for this one, in this circle, what's our radii? P to what? Yeah, P to E would be the same as PF, which is the same as PD. So before, in a circumcenter, we were going from the circumcenter to the vertex, to the angles. This time we're going from the in-center to the edges, to the sides. So PE is the same as PD, which is the same as PF. On your practice today, that's going to probably be the biggest thing, is just identifying which one you're working with. Are you working with a circumcenter or an in-center? So that'll be the first step as you work through it. Which one is it talking about? And either it will tell you or it'll give you a picture, and you have to decide, do you have angle bisectors or perpendicular bisectors? All right, so as I take a look at our last problem here, we have S is the in-center of triangle MNP. So MNP is our beginning. And the in-center is always going to be on the inside. So what I know is I'm going to start off with our angle bisectors. So what would be an angle bisector here? From what do you got? Yeah, S is going to be the in-center. And then an angle bisector would be from S to what? We're going to an angle. That one's just 90, so I want to go I want to go to an angle of this triangle, MNP. So S, no. I love that you guys are guessing. S to N. Those are all really good tries there. We're looking at these ones here from this triangle. So we're going to go S to N, and then we're going to go S to, what's another angle in this triangle? M. And then S to P. So those are the angle bisectors. Now this triangle is not drawn to scale, because as we look at this next part that's created, the next part is that circle. If I drew a circle, would it really work with that? Is that a circle? No. So it's not drawn to scale, which just means that the numbers don't really match the picture. But since we're given numbers and we're given this information, we have to assume that the picture was just drawn really bad. Okay, so from S, I know S to U will be the same as, good, which will be the same as S to R. So if I want to know SU, how long, what's the distance of S to U? Six. How did you know? Good. T to S is 6. And remember, TS is the same as SU, which is the same as SR. All right, the next thing that we're going to do is find the measure of angle RPS. Last part of your notes today. We're going to find the angle of RPS. PSR is a right angle. So RPS, if I start at R, I go to P and then up to S. I'm looking for this angle right in this corner here. So we can sneak in a little question mark or an X or a star saying this is the one we're looking for. Now, there are so many strategies to find this. Last year, I remember working with a student, and they found the right answer, and they tried to explain to me how they got there. And, like, eventually I was like, okay, like, yeah, I guess that makes sense. Like, mathematically, that's sound, but it's just not the easiest way I would do it. So there's so many ways to find this answer. I'm going to show you the way that I would do it, but as you're working through your practice today, you might notice that you did it a different way, and that's fine. Okay, so what I would do personally is I'm going to look at this whole triangle, MNP. I'm going to redraw it over here. So I have M, N, and P. I'm looking at the overall big triangle. That helps to color code it. You can. I don't know why I didn't color code the triangle before, but I didn't. And I know that each of these are angle bisectors. So when I look at angle M to S, cut that angle in half. So this part of the angle is the same as this part of the angle. So if the bottom half of the angle is 31, the top half of the angle is also 31. Sorry, that's hard to read. That says 31. So then how much is the overall angle at M together? 62. So at angle M, I'm going to put 62 there. Okay, now I want to find angle N, how much angle N is. So I know if one side is 28, the other side is also 28. Good. Abdirman did that in his head already, and he found the answer. 28 and 28 together is 56. If I knew the other angle on this one here, it would be really easy to find the other angle, because I would just copy it and say, yep, that's it. But I don't know either one, so I'm missing this whole angle P. Not quite. Whoa, you guys are crazy people. All right, so how do I know, how can I find a missing angle in a triangle? Good, subtract both numbers from 180. So however you do that, some of you I know do the 56 plus 62. You can do that. I just do 180 minus 56 minus 62. Use that handy dandy calculator that we carry around. We get 62. So I know angle P is now 62 degrees, is the whole angle. When I look back at what I was trying to find, was I trying to find the whole angle? No, I just wanted the bottom half. So how can I take 62 if I have an angle bisector? How can I take 62 and split it? Good, divide it by 2. So 62 divided by 2. Again, just use a calculator if dividing is hard for you. I'm not testing on you. Do you know your division facts? Our answer is 31. So now go back and write that answer. It's going to be 31. And then what's my label for angles? Feet, inches, months, degrees, years, degrees. That little circle. Good. You guys crushed it. Okay, there is practice.